We're going to use the 3 steps to sketch method to graph a basic unshifted secant graph, y equals secant 4x. So here's our template. It'll keep us organized and on the right track. Here's our grid. And let's start by noticing that our equation is in the form y equals a secant bx. So we know we should be using the basic template for secant graphs, and that's when we do not have any shifting going on. So now that we know that, we can jump into step 1, where we'll find our companion equation and its essential information, as well as our asymptotes for our final graph. So the companion equation is simply going to be an equation that we graph to then help us get the real graph that we want. And it's simply the reciprocal graph. So just replace secant with its reciprocal, cosine. So our companion equation will be y equals cosine 4x. If you don't know how to graph cosine yet, I highly recommend you go check the links in the video description. There will be one there for graphing cosine equations. It's great to go ahead and master that skill before moving on to these cosine graphs. All right, so let's go ahead and get all the information we need to graph a companion graph, y equals cosine 4x. A is the leading coefficient, an understood 1, and that tells us our amplitude is going to be 1. So that's the distance from midline to either max or min. B is going to be the coefficient of x, that's 4. It tells us we have 4 cycles that happen between 0 and 2 pi, and we also use it to calculate the period. So we do 2 pi divided by b, and we see 2 pi divided by 4 reduces to pi over 2. So that's our period, the length of a horizontal cycle. Okay, once we have all that, we can set our scale labels. This will be how we count each tick mark. And we do set a very intentional scale label for our horizontal axis so that our graph points align nicely with our horizontal tick marks. Take your period and divide by 4. All right, so pi over 2 divided by 4 is going to be pi over 8. So that'll set a really nice scale for our horizontal axis. And your vertical scale, you can usually just count by 1. And that's what we'll do here. So let's take a minute and go ahead and label our axes. So starting with the horizontal axis, we'll count by 1 pi over 8. So we have 1 pi over 8, 2 pi over 8, which reduces to pi over 4, 3 pi over 8, 4 pi over 8, which reduces to pi over 2. It's always good news when that 4th tick mark is your period, because we took our period and divided by 4, so that's a good sign. We are on the right track. All right, we're at 4 pi over 8, so now we have 5 pi over 8, 6 pi over 8 reduces to 3 pi over 4, 7 pi over 8, and 8 pi over 8 reduces to pi. So following along, take a second to pause. I'm going to pause so I can label the negative side of this axis. It'll be all the same values, just of course with negative signs. So here's what the finished horizontal axis should look like. And then of course for our vertical axis, we're just counting by 1. So we have 1, 2, 3, and -1, -2, -3. So we're all set up to go on to step 2, where we're going to plot our companion cosine pattern. But before we do that, let's take a moment and find our asymptotes equation for secant. So we're switching gears a little bit here. This will be something that helps us for the final equation. It'll basically give us a way to double check that our graph is accurate. So the asymptotes of secant happen wherever cosine had an original 0. And if you know the graph of y equals cosine x, you'll know that the zeros happen at pi over 2 plus pi k. And since secant is a reciprocal graph of cosine, whenever you try to take the reciprocal of a 0, of course that is undefined, and that's why we have those vertical asymptotes there. So to find the equation that will give you all of the asymptotes, all you need to do is take the inputs of your original secant graph and set them equal to pi over 2 plus pi k. So we'll do that scratch work here in the top right corner. 4x equals pi over 2 plus pi k. And here k is an integer, and we'll talk a little bit more about that. So it's kind of a placeholder there to generate all of the asymptotes that we'll want. So all we have to do now is solve for x. So divide each term by 4, or multiply by 1/4 if that helps you. And let's write our final equation in our template. So our asymptotes are going to happen at x equals pi over 8 plus pi over 4k. All right, so a little bit more about how k works here. Depending on what integer you substitute in for k, you'll get a different asymptote along your graph. So if you let k equals 0, you see that you'll have an asymptote at pi over 8. So we'll check that on our final graph. If you substitute in k equals 1, you'll get the next asymptote moving to the right. And you see if you simplify that, if you do the calculation out, you will get an asymptote at 3 pi over 8. If you let k equal to negative 1, you'll substitute in, simplify, you should have an asymptote at negative pi over 8. And so that's just a neat thing to play around with, plug in different values for k, and get familiar with that because it's really, really helpful. Of course, like I said, to double check your graph, but sometimes you just want to know where an asymptote is. And this is a quick, easy way to find them all. All right, so now that we're done talking about asymptotes, let's switch gears back to our companion pattern. We're going to plot our companion pattern lightly. This is step 2, so that we have that as our base to take the reciprocal of. Okay, so remember that the pattern for a cosine graph that is not reflected is going to be maximum x-intercept, minimum x-intercept. So our maximum will happen, of course, on the y-axis is where we start, and look to A for the y-coordinate. So our maximum is at 0, 1. And then at the next horizontal tick mark to the right, we'll have an x-intercept. The second horizontal tick mark will be our minimum. And look to A, take the opposite of A to get its y-coordinate. Okay, then we have another x-intercept at our next tick mark, and then the pattern would repeat. So very lightly again here, this is not our graph, it's just the reciprocal, but we're going to use it in the next step to get the graph of secant, which is the one we want. All right, so we are ready for step 3. We will recip, sketch, and repeat. So recip just means take the reciprocals of the y values. Okay, so you may know what the secant graph looks like, and if you know that each of the maximums turns in of our companion cosine graph, each maximum turns into a local minimum for the secant graph, and then each minimum turns into a local maximum, you may just be able to see that if you've graphed enough secant graphs. If not, go through it like this. The reciprocal of 1, of course, is just 1. And look here, you'd have about 1/2. So the reciprocal of 1/2 is 2. If you try to take the reciprocal of the x-intercept from the companion pattern, you have 1 over 0, which of course is undefined. And we sort of referenced that earlier. That is a huge key to tell us we have a vertical asymptote here. And look, that's what we said would be an asymptote if we let k equal 0. We have an asymptote at x equals pi over 8. Okay, we keep going, taking reciprocals. The reciprocal of negative 1/2 is negative 2. Of negative 1 is negative 1. Another negative 1/2 gives another negative 2. Try to take another reciprocal of 0. Gives you a vertical asymptote at 3 pi over 8. And that is what we said if we let k be 1 in our asymptotes equation. Okay, another quick few reciprocals here. Of 1/2 again is 2. Of 1 again is 1. And we have some really nice points to help shape our secant curve. We're ready to sketch. So here is what our secant graph looks like. So notice, especially if you're going to be graphing a lot of these secant graphs in the future, notice how the maximums from the companion cosine equation became these local minimums of the secant graph, and how the minimum of the companion became a local or relative maximum. So that's going to happen every single time. All right, now that we have a nice sketch of one cycle of secant 4x, we can repeat the pattern for as many cycles as we want. So I'll do that in purple here, moving first to the right. So we'd continue our secant curve here. We'd have an asymptote at 5 pi over 8. Play around with the asymptotes equation. That's your asymptote if you let k equal 2. We'd have another curve here with a local maximum. Another asymptote here at 7 pi over 8. That's when k equals 3. And then another partial curve with a local minimum. Okay, so that's another cycle. Let's work in the other direction here. So finishing out that curve with a local minimum. An asymptote at negative pi/8, we said that happens when k is -1. A curve with a local max. Another asymptote, that's when k equals -2. The curve that has the local minimum. Another asymptote when k equals -3. Another local maximum curve. And so you can see you're just repeating this pattern over and over and over again. Okay. The asymptote at -7 pi/8 would be if you let k equal -4 and finish out the graph here. So this is, let's see, 1, 2, 3, 4 nice cycles of secant 4x. And that's how you can sketch an unshifted secant graph using 3 steps to sketch. I'll post some links in the video description if you want to check out more worked examples or how to graph other trig functions using this method. Thanks for watching and good luck with your graphing.